Imagine opening your energy bill and seeing a zero. Not a credit, not a mistake, a zero. Every single month, every single year, without exception. That is not a fantasy. That is a Tuesday morning for an Amish family in Lancaster County, Pennsylvania. And what you are about to discover is the complete, unmodified system. They use a system that heats, cools, and powers their homes without sending a single cent to any utility company. Not solar panels, not wind turbines, nothing you have ever seen advertised in a home improvement store. This is older, simpler, and so devastatingly effective that several states have quietly written building codes specifically designed to stop you from doing it yourself. Stay with me until the very end, because the final technique I will share with you is something I have never encountered in a single modern construction guide. And when I understood why it was missing, everything about the modern energy system finally made sense. The average American family spends $2,400 every single year on energy. That is $24,000 over a decade. $120,000 across 50 years, money flowing directly into the accounts of utility corporations that have spent millions lobbying to make sure it keeps flowing. Here is the absolute foundation. Before an Amish master builder picks up a single tool, he stands on the land and watches where the sun travels. This is not mysticism. This is physics. Every Amish home in Holmes County, Ohio, is oriented with its longest wall facing within 10 degrees of true south. Every single one. This is called passive solar orientation, and it is the entire backbone of the system. A south-facing wall in the northern hemisphere receives direct sunlight from sunrise to sunset throughout winter, when the sun sits low on the horizon. In summer, when the sun arcs high overhead, that same wall falls into its own shadow. The house heats itself in winter and stays cool in summer through nothing but geometry. Penn State Extension has studied traditional building orientation for decades. Their data confirms what the Amish perfected through generations of trial. A properly oriented home can reduce its total heating load by 30 to 40% before you add a single other element to the system. Most American homes are built to face the street, whatever direction that street happens to run. The developer saves 20 minutes of planning. You spend the next 30 years paying the utility bill that decision created. But orientation is only the first layer. The second layer is where the Amish system begins to separate itself from anything you will find in a modern building supply store. Walk around an Amish home and something strikes you immediately. The south-facing wall is lined with large, deep-set windows. The north wall has almost none, perhaps one small opening per room, placed high near the ceiling. The east and west walls carry moderate glazing, carefully proportioned. Those large south windows act as passive solar collectors, pulling thermal energy directly into the living space throughout the day. The sills, 12 to 16 inches wide, create a thermal buffer zone that slows heat transfer and prevents cold drafts from stripping away the warmth the glass just captured. A standard modern windowsill is perhaps 3 inches wide. An Amish windowsill is wide enough to sit on. There is a precise reason for that. The old builders understood something about convective air movement that modern construction simply abandoned in the race to build faster and cheaper. When warm air rises along heated south windows and cool air replaces it from the shaded north, the room creates its own gentle thermal circulation. No fan, no electricity required. And then there is the summer solution. What about July in Ohio when the temperature climbs to 94 degrees and the air sits heavy with humidity? This is where the cross-ventilation system enters, and this is the piece that genuinely stunned me when I first saw it fully explained. Amish homes are designed with an internal geometry that creates continuous natural airflow through a principle called the stack effect. Cool air is dense and heavy. Warm air is light and rises. Place low intake openings on the shaded north side, where the coolest exterior air settles, and high exhaust openings on the south and upper sections of the house. Warm interior air rises and escapes, drawing the cool north air inward behind it, continuously, without a single mechanical component. A Lancaster County family showed me their 1887 farmhouse that uses this exact passive cooling system. The upstairs bedrooms in July stayed 8 to 12 degrees cooler than the outdoor temperature with zero mechanical intervention. I checked the thermometer myself, and here is where the building code problem becomes impossible to ignore. In Pennsylvania, Ohio, Indiana, and a growing list of other states, modern residential building codes require mechanical ventilation systems. If you submit plans for a home that relies on natural cross-ventilation as its primary cooling strategy, you will be required to install mechanical systems anyway. The natural system is not forbidden. It is simply made irrelevant by legal requirement. Cornell's Building Science Department has documented this regulatory pattern extensively. You are required by law to install systems that generate monthly bills, even if you have designed a home that does not need them. The utility industry has been lobbying for these code requirements since the 1970s. Draw your own conclusions about that timing. But the element of this system that truly stopped me, the one that kept returning to my thoughts for weeks after I first encountered it, is the thermal mass. Here is something most people have never been taught about heat. It is not simply a gas that fills a room. Heat can be physically stored inside solid material the way water is held in a tank. Adobe, stone, brick, rammed earth. These materials have high thermal mass. They absorb heat slowly through the day and release it steadily through the night. An Amish home built with thick stone walls does not simply stay warm because it is insulated. It stays warm because the walls themselves are a heat battery. A standard modern wall 2x4, framing and fiberglass, has nearly zero thermal mass. The moment exterior temperatures drop, it stops working. A stone wall 18 inches thick absorbs heat all afternoon and radiates it back into the room all through the night. This technique is 400 years old. The builders of the American Southwest knew it. Early European settlers who built in stone knew it. The Amish preserved it faithfully. Modern construction abandoned it in 1950 in exchange for walls that are faster and cheaper to build, and that guarantee you will run your furnace every single night of winter. Combine proper orientation, calibrated window placement, all passive cross-ventilation, and thermal mass walls, and you have a structure that maintains comfortable temperatures through brutal winters, with almost nothing in the way of fuel input. But there is still one more layer: the heating system itself. Now we arrive at the heating system itself, and I want to be careful here because, when I first encountered this, I was convinced someone was exaggerating. The Amish thermal mass stove, called a masonry heater, or Kasselofen in the German-speaking tradition from which most Amish communities descend, operates on a principle that is the near-exact opposite of every modern wood stove ever sold. A standard wood stove burns slowly, incompletely, and continuously to maintain temperature. It requires constant feeding. It produces significant creosote. The heat it generates rises and disappears before the room can absorb it. A masonry heater burns hot, fast, and complete. You light a fire that burns with fierce intensity for 1 to 2 hours, perhaps 3 large pieces of wood at most, and then it goes out. Done. But the firebox and surrounding mass of stone, brick, and clay, which can weigh between 3,000 and 5,000 pounds, has now absorbed an enormous quantity of thermal energy. That thermal mass then radiates the stored heat slowly and evenly into the living space for the next 18 to 24 hours. The surface of the stove never reaches a dangerous temperature, warm enough to be a pleasure to lean against, never hot enough to cause a burn. Children sit beside it. Animals rest against it. It is categorically safe. Auburn University's forestry and wood science programs have measured masonry heaters at 80 to 90% thermal efficiency. The best modern certified wood stoves reach 60 to 70%. The combustion temperature inside a properly designed masonry heater exceeds 1800 degrees Fahrenheit. At that temperature, the burn is nearly complete. Creosote deposits are minimal. Chimney fire risk approaches zero. An Amish family burns 3 to 4 cords of wood across an entire Ohio winter. Wood they cut from their own land. Their heating bill, zero. Their dependence on a utility company, zero. Compare that to the $1,400 average American heating bill that arrives every single year, year after year, decade after decade. Now I want to give you the one piece of this entire system that I have genuinely never seen documented in any modern home improvement resource, any homesteading publication, or any single video in this space. I found it buried in a 1903 USDA agricultural survey of Amish and Mennonite settlements in eastern Ohio. It concerns how they manage the thermal mass of the floor itself. In the older Holmes County settlements, the earthen or stone floor of the main living area was constructed over a network of clay pipes or channels, roughly 4 to 6 inches in diameter, buried 6 to 8 inches below the surface. These channels connected to a south-facing inlet near the base of the exterior wall. During sunny winter days, cold exterior air entered through this inlet, traveled through the underground channels, and warmed as it moved through the earth, which maintains a constant temperature of approximately 55 degrees Fahrenheit year-round at that shallow depth. The air emerged inside the living space pre-warmed by passive geothermal exchange. No pump, no electricity, no moving parts of any kind. The 1903 survey called this a ground tempering channel. The Roman builders of the 1st century called a related system a hypocaust. The Amish in Holmes County called it simply the floor breath. These civilizations, separated by thousands of miles and 19 centuries, arrived at the same elegant solution independently. The ground tempering channel added an estimated 8 to 12 degrees to incoming winter air before it ever made contact with the living space. Combined with the south-facing windows, the thermal mass walls, and the masonry heater, the result was a home that maintained 60 to 65 degrees Fahrenheit through the depths of an Ohio winter with a fuel cost of essentially zero. I have sat with that number for a long time. 60 to 65 degrees through an Ohio winter. 2 logs a day. No bill arriving in the mail. No dependence on a grid that can fail, a company that can raise its rates, or a government that can cut your supply. The question worth asking is this: why does any of this feel like secret knowledge? It should not. None of these techniques are patented. None require exotic materials. None require a college degree. A family with basic carpentry skills, access to stone, and a south-facing parcel of land could implement every single element of this system. The reason it feels obscure is not an accident. The moment this knowledge becomes genuinely mainstream, the moment ordinary families begin building homes that do not require utility connection, a significant portion of residential energy, demand simply disappears. The utility companies understand that. The building products industry understands that. The regulatory bodies they fund understand that. The Amish did not invent self-sufficiency as a lifestyle brand. They preserved it as a survival strategy. And somewhere along the way, the rest of us decided that paying $2,400 a year to be comfortable in our own homes was simply the price of modern life. It does not have to be. If you have ever stood in your kitchen on a February night, opening a bill that felt like a punishment for simply wanting to be warm in your own home, you now know that there was always another path. There still is. Which of these techniques surprised you most? Leave it in the comments because your answers genuinely shape what this channel explores next. And there is substantially more where this came from. If you believe that real, practical knowledge has been quietly sidelined to protect someone else's revenue stream, you already know what this channel stands for. Subscribe, because the next system we uncover goes even deeper, and it makes everything you just watched look like the introduction.